Good morning, geometry class. Hope everybody's doing well. Great job on your checkups, making sure you get those into me, those corrections for those who got below an 80. So good job on that. We're going to get started this morning, and so we're going to continue what we're going to do now. This last section of our book, 1119, we're going to look at some proofs. And so some of these informal proofs, we're going to look at how to prove these by using coordinate geometry. So before we do that, we're going to pray. Then we're going to just go over a couple of our homework problems, and then we'll get into our new topic. All right, so let's pray, and then we'll get started. Lord, bless our time together. Without you, we can do nothing. Give us wisdom. Me as the teacher to explain these rules and theorems and principles, the students to apply it, and to work hard and diligently. And we'll thank you in Jesus' name. Amen. All right, we're going to begin on page 34. Page 34, for homework we had to do, I believe, number 5. We're going to do homework for number 5, so we're going to put that on the board. So x squared plus y squared minus 3 equals 0. And what we did yesterday, just by way of review, we learned how to graph circles. So up until this point, we've been graphing straight lines, finding the midpoint, finding the distance, right? Finding the slope, all of straight lines. Yesterday we learned how to graph circles, and so page 33, we looked at the equation of a circle is simply x squared plus y squared equals r squared. And so if we're going to graph a circle with their origin, all right, so with the center of the circle at the origin, we're simply going to have to put this equation in this form. So for number 5, we did for homework, we have x squared plus y squared minus 3. And so simply we just need to manipulate this equation to get 3 to the right-hand side of the equation. So we're going to add our addition axiom of equality. So x squared plus y squared equals 3. X squared plus y squared equals 3. And then since we have r squared in our formula here, we want to figure out what the radius is. So r squared equals 3. And then once we do that, we find the square root of both sides. And then r will equal, let me see here, r will equal, what is number 5? 1.73. 1.73. Now, if you're going to graph that, 1.73 obviously would be right between 1 and 2, and then closer to 2. And so that would be the radius. So from your point 0, 0, you would go 1.73 spots to the right, 1.73 spots up, 1.73 spots to the left, and 1.73 spots down, and then draw your circle there. So anytime you're dealing with decimals, so obviously it's not going to be totally accurate, but you want to be closer to 2 on those graphs there. Okay, so then look at page 36. And so also we learned how to graph circles that are that their center is anywhere on the graph, not just on the origin. And so to look at that formula, we did x minus h squared, okay, x minus h squared plus y minus k squared equals r squared. Okay, and then for homework, we just simply had to do number 7 and number 9. So let's quickly do those together, number 7 and number 9. So for number 7, okay, the equation is x minus 1/2 squared plus y minus 1/2 squared equals 1/4. All right, now for this one, what we're going to do is we're going to take each segment of the equation and make it equal to the new equation. So how we do that is we go x minus h equals x minus 1/2. Okay? And then for y, we're going to do the same thing here. Since I'm put on this side of the board, y minus 1/2, y minus k equals y minus 1/2. And then we want to find the radius. And so we would go r squared equals 1/4. Okay? So these are going to give us our coordinates. All right? So this one here will give us our coordinates. And then here will give us the radius. Okay? So let's quickly solve. Since we have x on both sides at equal sign, x's cancel out. And so we have negative h equals negative 1/2. And then all we're going to do there is multiply by negative 1. So we have h equals 1/2. So, all right, our first plot would be 1/2. And then our second one, we're going to go, since y is on both sides of the equation, they cancel out. So negative k equals negative 1/2. And again, multiplied by negative 1, k equals positive 1/2. So there are our coordinates. So go on your graph, and you're going to graph 1/2 over. So now, obviously, that's going to be between 0 and 1, okay? And then 1/2 up. So 1/2 over from 0, 1/2 up. And then now let's see if we can find the radius from that spot. So obviously we want to get rid of the exponent. So we're going to find the square root of both sides. So r equals 1/2. And so from your center, 1/2, 1/2, you're going to go 1/2 to the right, 1/2 up, 1/2 to the left, 1/2 down. And you'll have a little circle, but you're going to connect all those points there. And there you have your circle on the graph, okay? Let's do, that was number 7. Let's do number 9 quickly. Just by way of review. Number 9, we have x minus 6 squared plus y plus 1 squared equals 4. Okay, so now get our equation. So we're going to go make each section of our equation equal to our equation that gives us a graph of a circle that's not at the center, origin's not at the center. So we're going to go x minus h equals x minus 6. And then we're going to go y minus k equals y plus 1. And then we're going to find r squared equals 4. So let's find our center for our circle, and then we'll find the radius. So again, x is on both sides. Negative h equals negative 6. H equals 6. Okay? And then here, y's cancel out. Negative k equals positive 1. Multiplied by negative 1. And we have k equals negative 1. So our center on your graph is going to be 6, 1. Okay? So obviously this is your x coordinate. This is your y coordinate. So 6 spots to the right, 1 spot up. Mark that on your graph. That's the center. Now the radius, we're going to find the square root of both sides. R equals 2. And so from 6, 1, you're going to go 2 spots to the right, 2 spots up, 2 spots to the left, 2 spots down, and then you connect your dots and form a circle, and there would be the graph of a circle whose center is not at the origin. All right? Any further questions? Listening students, feel free to contact me and any additional questions or additional help that you may need. Now we're going to look at page 37, and we're going to get into these coordinate proofs. So now we're going to take our coordinate geometry, what we've learned, and then we're going to apply it to proving triangles and parallelograms and different things like that. So looking at the top of the page 37, we are now going to apply the coordinate system to proofs. When drawing figures on a coordinate system, now every time I'm talking about a coordinate system, I'm talking about a coordinate plane, okay? A coordinate plane. So it is important to place the sides of a triangle or a quadrilateral along the x-axis or y-axis and one of the vertices at the origin. So again, if you look at the picture here on your page, top of your page, notice we have the coordinate plane right there, and then we draw a triangle, and notice, okay, at the origin is one of the vertices, okay, and then obviously the sides of the triangle are parallel to the x-axis, parallel to the y-axis. Here we have a parallelogram. Again, notice one of the vertices will always be at 0, 0 at the origin. And then simply we have our shape drawn on the coordinate plane. So what we're going to do is we're going to learn how to prove these shapes. But before we do, I want you to draw your attention to the second paragraph. There's 2 very important things that we want to know. After drawing the figure on the coordinate plane, we need to identify the coordinates of each vertex. If the vertex, now you want to highlight this, you want to know this is very important, especially for the next few pages. If the vertex is along the x-axis, the second number of the ordered pair will be 0. So anytime we have a shape on our coordinate plane and we have a line that's on the vertices on the x-axis, the second number will always be 0. Likewise, if the vertex is along the y-axis, the first number of the ordered pair will be 0. So notice, okay, again, we're going to be looking at these shapes, and we're going to see where the line lays. If it lies parallel to the x-axis, if it lies on the x-axis, then we know the second number will be 0. The second pair of the ordered pair will be 0. If it's parallel to the y-axis, then we know that the first number in the ordered pair would be 0. We will use different letters of the alphabet in place of numbers, as few variables as necessary. If one number is A and another number is twice that number, instead of calling it B, we will call it 2A. This will make the solution much easier. If we have too many variables are introduced, the solution may not be possible. Now, I want to draw your attention to the very first one on the example. All right, so I'm going to draw a coordinate plane. Okay, now notice the shape that we have here. We have a parallelogram, and one of the vertices is at the origin. We're going to call that A. Okay, then we go, all right, I'm sorry, this is B. This is C. Okay. Not very good. D. Okay, we have a parallelogram there. Okay, so now notice A. What is the points on A? So what would be the coordinates of point A? Since it's at the origin, the coordinates of A would be what, class? At the origin, it would be 0, 0. Okay? Now, okay, notice B. What are the coordinates for point B? So notice we would have, since it's in the second quadrant, we know that it would be negative, positive, right? And so instead of adding another variable, we're going to call this negative A, and since it's parallel to the to the y-axis, okay, we have negative A, and then we're going to call this B. Let's go to point C here. What happens to point C? Now, point C would be the direct opposite of that. It's the same line, but it's on the first quadrant, which we know both numbers would be positive. So in this one, we'd have negative AB, and C would be, okay, it's the same side, all right? So, or it's the same coordinates, just on the opposite side. So we would have positive A, positive B. And then what are points D? Since it's, okay, now let's look at this. I'm going to kind of, all right, you see the bottom line of this parallelogram? Okay, would you say that this line is parallel to the x-axis? If it's parallel to the x-axis, then the second number in the ordered pair would be 0, right? And then the first pair would be, again, we're not going to add another variable. That would be too hard. We're going to say that would be 2A. And there are your coordinates. And so we're gonna label these coordinates in the very next section here. So numbers 1 through 6. We're gonna look at these various shapes. I have a couple up here on the board, 1, 3, and 5. We're gonna label these coordinates and then hopefully give you some practice and then get you to do it on your own. So let's look at number 1 together. All right, we have a square. We have a square. Okay, see, I drew this one up on the board. Okay, we have point C is, just using letters to represent numbers, TT, and D would be, obviously since it's on the x-axis, the second number would be 0, right? And the first number would be T0. Okay, again, these are representing numbers. We just don't have numbers here, they're representing numbers. Now, point A, where would that be located? At the origin. So my coordinates for A would be 0, 0. Now we're going to come up here to point B. What are the coordinates for point B? Now, since it's, okay, let's look at this line. Okay, would you say that that line's parallel to the y-axis? If it is, then the first order pair, right, would be what? 0. Remember, if the line's parallel to the x-axis, the second number is always 0. If it's parallel to the y-axis, the first number is always 0. And then, obviously, what would we have here for the second part for the y? Well, if this first part is x, and this second part is y, right? Notice again, we're going to graph this point here. It would be on the same same as the y-axis there. So we would say 0, t. 0t. Again, because it's on the same line, right? If this is the y-axis, this is the y number here. So we know the y number is t. And since it's parallel to the y-axis, the first number is 0. So 0t would be your coordinates. So I think for that one, you just had to do A and B, right? So A is 0, 0, and B is 0t. Let's look at number 3. We have a right triangle for number 3. Again, we have the vertex. We always have one of the vertices of the shape is always at the origin. So we know K is 0, 0. We want to find J, all right? We want to find J and K, okay? J and K. So let's look at J first. Okay, now would you say that this line is parallel to the x-axis? If it is, then what's the second number in our ordered pair? Okay, if it's parallel to the x-axis, the second number will always be 0. Okay. Now, what's the first coordinate? So if we're just simply using the letter A here, so my first coordinate here would simply be A, 0. Now, what's the coordinate for K? Where's it located? At the origin. So K would simply be 0, 0. Let's look at number 5. Number 5. Okay, we have an equilateral triangle. An equilateral triangle. Again, so we see how we've drawn this down. Okay, obviously we have one of the points is one of the vertices of the triangle is located at the origin. All right, so we want to figure out what point Q is. What are the coordinates of Q? Now, what kind of triangle is this? Equilateral triangle. Does anyone remember from, I think it's last page, maybe 2 pages ago, 11:17, when we learned about how to find the sides of right triangles, and particularly an equilateral triangle. Does anyone remember that? How do I find the side of an equilateral triangle? Wouldn't it be A to the square root of 3? Yes, A. So this would be simply A to the square. So, all right, now we want to obviously look at the first here. So obviously we have A. And then the second one would be A to the square root of 3. There would be your coordinates there. So A to the square root. And the reason why it's A to the square root of 3 is because this is an equilateral triangle. And how do we find the length of an equilateral triangle? A times the square root of 3. All right, so I want you to do practice 2, 4, and 6. 2, 4, and 6. All right, we're going to look at page 38 now. Now, once we have a figure placed properly on the coordinate plane, we are ready to begin the proof. So we just looked on the previous page here how to place a shape on the coordinate plane. Once we're able to do that, now we're able to begin the proof. And many of the proofs in upper level math courses use the informal approach as we have used and will continue to use in this pace. Several formulas and theorems in this pace will be used in coordinate proofs. Below is a list of some of the ways that they may be used, okay? So if I want to find the midpoint formula, right? So using the midpoint formula, now, this is very important because we're going to apply these very proofs in the next page that we're going to. So, the midpoint formula. When should I use the midpoint formula? For proofs dealing with the midpoint or 1/2 the length of a segment. Next page, we're going to use proofs. So, how do I know when to use the midpoint formula? When we're dealing with the midpoint of a shape or if we're dealing with 1/2 the length of a segment. So we are going to use the midpoint formula. I hope you memorized the midpoint formula. Remember, it's x1 plus x2 over 2 and y1 plus y2 over 2. Right? That's the midpoint formula. How about the distance formula? When do we use the distance formula? Now, the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. So when will we use that? If we need to prove that two lines are the same length. How about the slope of a line? If you need to prove two lines are parallel to each other, or if you need to prove two lines are perpendicular to each other. Now, I know right now it doesn't mean anything to you, but in the next few pages, we're going to be proving parallel lines, congruent lines. So these become very important to us, this little section here. And then lastly, the equation of a circle. And when do I use the equation of a circle? If you need to prove that two circles are the same size. And so all the theorems that we've learned in this pace are basically just equations. We're going to use those equations now to use coordinate geometry. Now, let's look at number 1 on page 38. All right, so let's just see when, all right, if we're capable of knowing when to use which formula. Number 1. Okay, the opposite sides of a parallelogram are congruent. The opposite sides of a parallelogram are congruent. If we're proving the lengths of sides, what formula or what theorem would I use? Look up top. All right, you want to look up top here from your section that we just looked at. Which one of these formulas would be used to prove line segments congruent? Think about it carefully. Very good. It would be the distance formula. The distance formula is, I'm just going to write that up on the board here, D equals square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. Remember, if we're proving any lines congruent, we're going to simply use the distance formula, which is theorem 102. And again, you don't have to write the whole formula. If you just want to simply write the equation, that's good enough for me. That's all we really need to know. Look at number 3. Number 3. Well, I'll read number 2, you answer it, and then I'll do number 3 together. The segments joining the midpoints of the sides of an equilateral triangle form another triangle. I see a key word in that section. I see the word midpoints. Which theorem would we use to prove the segments joining the midpoints of the sides of an equilateral triangle form another equilateral triangle? Number 3, we'll do number 3 together. If two lines in the same plane are perpendicular to the same line, then they are parallel to each other. Well, which one of these up here of our selection dealing with parallel or perpendicular lines? Very good. If two non-vertical lines have equal slopes, then they are parallel. That is simply theorem 109. Very good. Number 4. In a plane, if a line is perpendicular to one of the two parallel lines, then it is perpendicular to the other also. All right. Now, I'm not going to answer that one. We'll answer that one tomorrow. I want you to do that one on your own for homework. But notice, I will say this, a couple pages ago, we learned a theorem about parallel lines, and we learned a theorem about perpendicular lines, intersecting lines. So make sure you properly diagnose that. Number 5, we'll do number 5 together and before we go on to the next page. The diagonals of a rectangle are congruent. So anytime we're proving sides congruent, length of segments congruent, what do we use? We use the distance formula. The distance formula, all right? So these proofs, these theorems that we've learned in this pace, we're going to use them now for these indirect proofs, all right? So let's turn to page here, page 39. Page 39, we're going to do this one together, all right? Now this is, believe it or not, that's one proof, okay? That's one proof. We're going to quickly look at this. So let's write our given. We have a right triangle, ABC, and we want to prove. Now look at what we want to prove. So this, remember, when we're doing proofs, we always want to look at what we have to prove because that tells us what theorems we might need to prove that. We want to prove that segment AD is equal to BD, which is equal to CD. Now before we do this, okay, we're proving segments equal. If we're proving segments equal, what do you think? Which one of the theorems that we're going to be using? We're going to be using the distance formula. Very good. Now, let's draw this on our coordinate plane, okay? So we have our y-axis, our x-axis. Now we're going to draw the shape. Remember, since we're drawing a triangle, obviously the legs of the right triangle are going to be parallel to the x and y axis. Okay? And then, all right, we have our hypotenuse here. This is triangle A, B, oops, C, okay, A, B, C. And now notice our coordinates. I'm going to draw the coordinates up here. Okay, so we have obviously 0, 0. We have 2, B, 0. We have, all right, we have a midpoint here. D is B, A, and then 0, 2, A. Okay, there's all of our coordinates. Now let's prove, okay? Now let's look what we're proving here. Excuse me. AD. Now notice here, we want to prove that this line segment is equal to this line segment, and which is equal to this line segment. How do I prove? Now before we, right, we're going to use the distance formula. Excuse me, we know that. But before I can do that, I want to find the length of each of these segments. If I can find the length of these segments, then I can prove that they're all equal. So anytime we have, right, we have see this line CD? It originates at the vertex of a triangle, and it goes to the third side. It divides that third side evenly, right? And so what we have here, point D, would be a midpoint. It would be a midpoint. So let's follow along here. Number 1, we have placed right triangle ACB in the coordinate plane so that the right angle is at the origin. All right, there's our right angle at the origin. And the two legs are along the x-axis, okay, and the y-axis. And the coordinates of A are 0, 2A. The coordinates of B are 2B, 0. And we use 2A and 2B to avoid fractions in math. Since we are working with the midpoint of the hypotenuse, obviously that's what that is, we will now use the midpoint formula to find the coordinates of D, the midpoint of AB. Okay, now what is the formula for the midpoint? Okay, the midpoint equals, remember this, x1 plus x2 over 2, y1 plus y2 over 2. Okay, now, since we're working with the midpoints of the hypotenuse, we will use the midpoint formula to find the coordinates of D. To find the coordinates of D. So what's x1 and what's y1? Okay, so 0, remember, we're dealing with these numbers here. So 0 to A, so I'm going to put that here, just write it down so we have it, right? 0 to A, that's x1, y1. And then what would be x2, y2? So x2, y2 would be right here. So 2b, 0. I'm going to, now here we go. I don't want you to get confused here. Just write these down. We're going to plug these into our midpoint equation and find the midpoint of the line. So let's do this. Once I find the midpoint, I'm going to plug it into our distance formula, and we're going to see if these three line segments are congruent. So let's find this out. Ready? So m equals, x1 is, class, 0 plus, okay, x2, which is 2b over 2. And how about the next one? So y1, which is 2a, plus y2, 0 over 2. All right, now let's quickly add it. So obviously, what's 0 plus 2b? 2b. Now, I'm going to take it one step so we can see exactly what's happening here. So we have 2b over 2, right? And then how about, we have 2a plus 0 equals 2a over 2. Now what happens to my numbers here? They cancel out, don't they? 2 goes into 2 one time. So now what's my midpoint? Here it is. What's my coordinates for the midpoint? Here they are. B, A. That's how we came up with the coordinates B, A. Now now that we have B, A, now we're going to use the distance formula. Look at step number 3. The distance formula is now used to prove that two lines are the same length. With the coordinates of D, we now use the distance formula to find the lengths of AD, BD, and CD. Okay, so we're going to be doing the distance formula 3 times. Okay, we want to look here, pay attention here. So AB, right? Is that what it says there? AD, right here. Wish I had a different color marker. AD. Notice it has a set of coordinates, so we're going to plug them in. And then we have DB and CD. 3 times. All right, we're finished with this. Here we go. All right, let's plug this in here. D equals the square root of x2 minus x1 plus y2 minus y1. Okay, let's plug this in. We're going to the first line segment we're going to figure out is, let's do AD. Okay, so let's write the coordinates of AD so we don't get confused with my mess on the board here. Okay, ready? x1, y1, x2, y2. Okay, let's plug those in to our equation here. So we have the square root of x2 minus x1. So b minus 0 squared plus, okay, y2 minus y1. So a, right, minus, right, y2 minus y1, a minus 2a squared. Now let's quickly solve what's inside our parentheses here. Again, you can follow this along here. So we have b minus 0 is b. b times b is b squared. All right? Plus, now notice here. What's a minus 2a? What's 1 minus 2? Negative 1, right? So negative a. So negative a squared simply is positive squared. All right, so we have, so line segment AD is equal to this, all right? Now let's quickly move on here. Let's quickly do the next one. What's the next line segment? BD, all right, so let's solve for BD. Points B would be 2B, 0, and point D obviously is BA. All right, let's plug in our distance formula, okay? x1, so it's x2 minus x1. So x2 is b minus x1, which is 2b squared, plus y2 minus y1, so a minus 0 squared. I'm going to show you something here. So remember, we had to prove the lengths of these sides congruent. So here's the length of the first side. Let's see what the length of the second side is. b minus 2b is negative b. Negative b squared is positive b squared. Plus, a minus 0 is a squared is, would you notice now, what's line segment BD equal? Is that the same thing? Draw your attention there. Is that the same thing? Yes, it is. All right, let's look quickly find CD. All right, I'm going to erase this here. All right, because I don't have room. So let's do this last one. So how do we find CD? So C is 0, 0. D is BA. All right, distance formula. x2 minus x1 squared plus y2 minus y1 squared. All right, let's figure this out here. D equals x2 minus x1. So x2 is b minus 0 squared. All right, plus y2 minus y1 is a minus 0 squared. So we have b squared plus a squared. What did you notice? That AD equals b squared, the square root of b squared plus a squared. CD equals the b squared plus a squared. And BD equals the square root of b squared plus a squared. So now, what have we proven? Since AD, BD, and CD are all equal, then we can conclude that, here it is, that line segment AD is equal to BD, which is equal to CD. All right, so we will continue this on Monday. And so what I want you to do for homework is simply, I want you to do page 37, page 38, finish that. And then I want you to do the checkup. I want you to do the odd numbers on page 43. The odd numbers on page 43. Okay, that will be due on Tuesday, so be sure you get that in on time, and then we'll be ready to take our checkup. We'll be prepared for taking our self-test this coming week. All right, so have a good day, everybody. Bye-bye.